Hello everyone, welcome to this session on web scraping using R, brought to you by Rsquared Academy. Now before we get started, let me show you a few places where you can find and connect with us. You can visit rsquaredacademy.com to access all our R courses for free. We have a few beginner friendly R packages and Shiny apps. You can find the source code of all these packages and apps along with our course materials on GitHub, and you can find us on YouTube, Twitter, Facebook and LinkedIn as well. Now let us take a quick look at the agenda for this session. We'll explore the what, why and how of web scraping. Next we'll look at a few use cases before learning the basics of HTML, and then working on a few case studies where we will scrape data from real websites. So what is web scraping? If you look at websites, they are designed for human consumption and not for data analysis. Now web scraping is the process or technique of extracting data from a website and then tidying or reshaping it into a format or structure suitable for data analysis. Now how do you do web scraping, right? So the first step is to fetch the web page, right? So when we say fetch the web page, we are not actually going to fetch it in this format, right? So if we take this website, what we'll be fetching is the underlying source or HTML code of the web page, right? So we'll first fetch it as a XML document using the XML2 package in R, and then we will extract the content that we are looking to examine using the rvest package, right? So the fetching is done using the XML2 package. Then we'll use rvest to extract the content we want to analyze using rvest, and then we'll clean it up or reshape and store it in a particular format. So in R you might store it as a data frame or table, and finally you will analyze it to get some information or generate some insights. Now why do you have to scrape data from websites? So one reason is that a lot of websites contain useful information, valuable information, and we might want to use them for some project or analysis, right? And the second thing is you cannot copy paste, save or download the contents of a website, right? You can't just copy and paste it into R or Excel sheet or CSV. There is no save button or download button, right? So unlike saving images or videos, you can't right click and click on save image or save link or download, right? So you don't have any of those options. And the third part is that web scraping allows you to automate data collection from websites, right? So suppose you write a R script which extracts data from a website, and then it does some cleaning or tidying up of the data and stores it in a particular format. You can ensure that that particular script is run every hour or once in a day. You can schedule for that script to be executed, and the data will be collected and stored, which you can further analyze, right? So the first point is that websites contain a lot of useful information. The second thing is that you can't copy paste, save or download the information present on websites, and the third thing is that you can automate data collection using web scraping. Now what are the use cases, right? So we look at a few basic use cases here. The first one is contact scraping, where the contact details of individuals or organizations is collected. This might include email ID, phone numbers, location, the social media IDs, etc. You can also use web scraping for collecting details of used cars, real estate listings, to compare price of product across websites. You can do some text mining or sentiment analysis on the reviews of products or services. And finally, you can monitor the price of a product at different times of the day, right? So you can keep monitoring whether the price is going down or going up, if some discount is being offered, and then you can probably go and purchase it when the price is at its lowest level. And so these are basic use cases, but whenever you have valuable information or data, in a website, you can always use web scraping. Now in this session, we are going to work through 4 case studies. In the first one, we'll scrape data related to the best-selling smartphones on Amazon India website, right? So we are going to collect the name of the brand, the color, the rating, number of reviews, and the real price as well as the discounted price. In the second case study, we'll collect information about the top 50 movies on IMDb, top 250, and we'll collect the following information, right? The name of the movie, title of the movie, the year of the release, the certificate, the number of votes, the rating, the number of votes, the gross revenue, etc. In the third case study, we'll collect information about the 50 most visited websites, and in this case we'll collect the domain, the category to which the website belongs, any changes in ranking compared to previous year, the average time spent on the website, average number of pages browsed, and finally we look at the bounce rate. In the fourth case study, we'll collect information about the governors of Reserve Bank of India. So we're going to look at the names, when they started their term, when the term got ended, how many years they served, and what was their background, right? That is whether they came from an academic background, whether some economist, or whether a bureaucrat before becoming the governor of the Reserve Bank of India. Now, you need to keep a few things in mind before you start scraping data from the website, right? So the first thing is that it is best suited for websites which are static and are well structured. If a website is not well structured, then extracting the data becomes a problem. And in one of our case studies, we'll show you how a badly structured website or web page will hinder your data collection. The second thing and the most important thing is to check the robots.txt file, and this file will basically specify who can or who cannot access and scrape data from a website. Now in our case studies, we'll use this package called robots.txt from ROpenSky, which will fetch the robots.txt file, and it will tell you whether or not you are allowed to scrape data from a website. The third thing is to monitor for changes in the design or underlying code of the web page, right? Because if the underlying code changes, then your R script may not work and you will end up with the wrong data or no data, right? So always monitor if there's any change in the design of the website or in the underlying code. The fourth thing to remember is if there's an API available, which is an application programming interface, always use it and don't scrape the data from the website, because using an API, it is easier to get the data you want, and it will also come in a structured format. And the last point to remember is that do not flood website with requests, right? Because if they see the load on their server is increasing, they will block your IP address and you will not be able to browse that website, or you will not be able to extract any data from the web page, right? So keep these things in mind. These are very important. Ensure that you remember these whenever you are scraping data from a website. Now, since we are dealing with websites, we need to have some knowledge of HTML, right? Because the underlying code is HTML, right? So if this is what you see in your browser, this is the underlying code that you will see, right? So we need to have some basic knowledge of HTML so that we'll be able to locate the content that we are looking to extract, and we'll be able to identify the HTML tag or element using their names or the associated class, right? So it is important that you have some basic knowledge. So we'll cover them here, right? So first thing is that a website or a web page has 3 different components, right? One is the HTML, which is responsible for the content that you'll see. Then there is CSS, which is basically cascading style sheets, which is responsible for the appearance of the content, right? So for example, if you have some text, what font is used, what is the size of that font, what is the color of that font, whether it is italic or bold, all these things are taken care of by CSS. And the behavior in the web page is handled by JavaScript. As if you click on something, what happens? How does the web page behavior, or how does that particular element behave? is handled by JavaScript. Now, for web scraping, at least in this session, if it is sufficient if you understand HTML and a bit of CSS, I will not have to look at JavaScript, right? So let us take a quick look at an HTML element, right? So HTML element starts with a tag. In this case, what you're looking at is a level 1 header, right? So H1 stands for level 1 header. You can see there's an opening tag, right? And there is a closing tag or a start tag and an end tag, right? And between these two tags you see the content, which is example heading, right? And in the opening tag you can see an attribute name called class and an attribute value called primary, right? So you need to remember these things. One is the HTML element within which the content is there. Can you identify the tag? That's the tag between which the content you want to extract is present. And can you find an associated attribute name or value, right? Because we'll be using HTML tags and we'll be using attribute value to locate the content that we are looking to extract, and using them we'll extract the content, right? Now here are a bunch of HTML tags that you can quickly browse through and keep in mind, right? So we'll come across these when we look at the source code here, right? For example, you have this tag here for hyperlink, right, which we have mentioned here, and then you have the tag for paragraph, the tag for list, right, ordered and unordered list, this one for form, right? So all these tags you can keep in mind. When you're looking at the content you want to extract, you just map it to the tag within which that content is present, and then we'll be able to extract that content. So just quickly browse through this. Keep in mind, when we start going through the case studies, we'll use some of this. Now here we are trying to present the HTML document in the format of a tree, right? So this is basically known as DOM or document object model. And what this helps is in, sort of visualizing this whole HTML code or document that you have in the format of a inverted tree, right? Because if you look at the image here, you can trace a unique path to each element, attribute, or the content within that element, right? Now we'll use a similar approach when we are locating the content we want to extract, right? So we'll see within which element the content is present, what attribute is associated with that element or tag, and then we'll use a combination of the tag and the attribute to locate the content and extract it, right? So this I just wanted to quickly give you a overview of this so that you can always trace a unique path. If it's a well structured HTML page, you can always trace a unique path to the content that you want to extract, right? So once you are able to do that, once you are able to locate that content, then you can use a combination of the tag and the attribute to extract that content, right? So as we were talking about attributes, these are some of the important attributes that you'll come across and use in your data scraping or web scraping, right? So the attribute class will define the style for a whole section or element or tag, right? That will define the style that will be followed by a particular tag, a particular element, or particular section of the web page. Similarly, ID will give a unique ID for the HTML element or section of the website. Okay, so keep these two in mind, class and ID, because we'll be using them, these two attributes, to locate and extract our data. This will become more clear as you start working through the case studies, but I just wanted to introduce you to these topics before we start the case study, right? So we have 4 case studies and we'll go through them one by one. So let us get started with the case studies. Now we'll look at the packages or libraries that we are going to use. The first one is robots.txt. This will help us figure out whether or not we can scrape data from a website. Then we will use rvest to extract the data from the web pages that we download. We'll use XML2 package to download the web page as an XML document, and then from that XML document we will extract the data using rvest. Now rest of the packages that we'll use for tidying up or reshaping the data that we extract, so that we can save it or store it in a format suitable for data analysis. The first case study that we are going to look at is scraping information about the best selling smartphones on Amazon India website, right? So let me show you the website, right? This is the website and this is the web page. The link for the web page is available in the slides as well as in the R script that we'll share with you, right? So here you can see there are 10 best selling smartphones listed, right? The total count is 10. Okay, and we can see the information such as brand name, and then there is the color, the RAM, which is 4 GB or 8 GB, and then storage capacity. Then you can look at the rating, number of reviews, and then there is the real price, and then the actual or discounted price, right? So we will extract the brand name and we'll extract the color. Will not be extracting the RAM or storage capacity because it is not shown in a uniform method, right? Because here you can see it says 4 plus 64 GB, right? So 4 is for the RAM and 64 GB is the storage capacity. But if you look at the fourth best selling phone, it says 2 GB RAM and 16 GB storage. So they are specified in different ways, right? And it becomes difficult to scrape the data when they are not structured in a uniform format. So we'll leave out the RAM and the storage capacity, but we'll try to extract the rest of the information, right? So the first thing that we'll do is basically check if we have the permission to scrape the data from this website, right? And for that we'll use the robots.txt package, and the function that we are going to use is paths_allowed, right? Whether we are allowed to go in this particular URL path and scrape the data. And the argument that we'll use for specifying the URL is paths, right? So you can see the paths argument here, and within quotes we have specified the URL of the web page from which we are trying to scrape the data, right? So let's also go back to RStudio here, and we'll start running our code, right? So the paths_allowed function will return a logical value, right? So it will either return true or false. If it returns true, it means you can access this web page and extract the data from there. But if it returns false, it means you are not allowed to scrape the data or access that particular web page, right? So here it returns true, so I'm going to assume it is safe to scrape the data from this website, right? So once we have checked the robots.txt file, the next thing that we need to do is to read that particular web page into R, right? And this we'll do using the XML2 package, right? It has a function read_html. You can see that here, right? So we'll use the read_html function, and we'll pass on the URL from which we want to read in the web page, right? So let us read this in. If it's a big web page, it might take a while to read in the data, and if you run this, you can see it is a XML document, right? It's not a HTML document, but it's basically a XML document. And from this we will now start extracting the information that we want to analyze, right? So let us go back here. The first information that we want to look at is the brand name, right? We want to collect the names of the 10 best-selling smartphones. Okay, so we are going to do a couple of things here. First we'll go and look at the source or the HTML code of this page, right? So for that you can right click on the web page which you are browsing and click on view page source, right? So here you will see the source of that web page. It is basically HTML, CSS and JavaScript, and this is the underlying code, but what you see here is basically for human consumption. It's information that is well structured for us to look at. Now here let us see where the information that we need is, right? So I'm going to search for #1, which is the #1 best-selling phone, right? That's this particular text, right? So I just search for this here, and you can see it here, right? Line is 21152, #1 best-selling. Now we want to look at the name of the brand, right? And that is present somewhere here, right? So can you see this? Samsung Galaxy M30 gradation blue 4 plus 64 GB, right? So this is the text that we want to extract for all the 10 phones, right? So let us see where this is located. So I can see this tag for the hyperlink here. That's the closing tag, right? So and the opening tag is on this side, right? So this is the opening tag for the hyperlink A, and the closing tag is here, and between the opening and closing tag you can find the text that we want to extract. Right now, if we just use this particular information, what will happen is it will extract all the hyperlinks that are present in this web page. But that is not what we want to do, right? We just want the hyperlink which contains the name of the brand, right? So we need to add some more information. Now if you see, this particular hyperlink is within this section, right? You have this section which starts with the div tag, and you can identify it using this class CRW title, right? So this hyperlink is inside this particular section. Okay, so now we'll try to use this combination, right? The tag, that is A for the hyperlink, and the class, which is CRW title. We'll try to use these two information and see if we can extract the brand name, right? So let us go to RStudio. So we read the web page, right, using read_html. Then we saved it into top_phones. Now we'll use the rvest package, right, and we'll use this function html nodes, right? So this will be used to specify the location of the content that you want to extract, right? So as we just decided, we figured out that the content that we want to extract, which is the brand name, is within a hyperlink. So I'm going to use the tag A here, which is the HTML tag, and then it is within a section which I can identify with the class CRW title. Now whenever you specify a class, add a dot before that, right? That is how classes are identified. If you are specifying an ID, you will use hash before the ID name, but whenever you are specifying a class, you will add a dot, right? So I'm just going to run these two lines, right? HTML nodes and the top phones into which we read the web page, right? So it is giving me some information here. Can you see this? Right, so it has extracted all the hyperlinks that are located within the section which has the class CRW title, right? So we are looking at 10 best-selling smartphones. You can see there are 10 lines here, right? So 10 hyperlinks have been extracted. Okay, now since we have located the content, we need to extract the text which is present between the opening and closing tag, right? So this is your opening tag of the hyperlink, and this is your closing tag, right? And between the opening and closing tag you have the text, right? So now we'll use another function from rvest, which is html_text. What this will do is it will extract all the text that is present between the opening and closing tag, right? So let us run this, right? See, here you can see the brand names. 10 phones, best-selling phones. You have the brand names of all the 10 best-selling phones, right? So first we identify the location of the content using a combination of tag and class, right? So the tag is for the hyperlink A, and the class is crw title, right? Using this, we extracted all the hyperlinks present within this within all the sections which are identified by the class crw title, and from that we extracted all the text which is present between the opening and closing tags, right, which gives us the brand name. Now if you see this, it is not just a brand name, right? So we also have the color and the RAM and the storage capacity details. So we don't need all of that. So what we are going to do now is we'll just use a few other packages and clean up what we are seeing on the screen. So first thing to do is, let me just clean this up here. So here you have all the brand names along with the color and the storage capacity as well as the RAM, right? So we are going to split this at this point where there is an opening bracket, right? And for that we are using the string underscore split function from string r, okay? And we are saying split the string at the point where an opening bracket is present. And because opening bracket is a special character, we escape it using double slash, right? So let us see what is the outcome from this one. Right, so now you can see it is returning a list here, right? And then in the first part, element of each you can see here is the name of the brand name of the mobile, and in the second part you have the color, the RAM and storage capacity. So we just need this part, right? So each element of the list has a vector of length 2, right? So this is a vector of length 2 and this is the element of the list. In total there are 10 elements in the list, and then there are vectors within the elements which are of length 2. What we want to do is we want to extract the first element of the vector within each element of the list, right? This is what we want to extract, these information, brand names. So we'll use the map underscore character function from the pur package and ask it to extract the first element, right? So let us run this part and see what happens. Right, now you can see the brand name, right? So first we split the brand name and the details of the color, storage and RAM, and then we extracted the brand names from that particular list. There's another problem here, right? There is a white space at the end of each of these names. So we'll use another function from string r, string underscore trim, which will trim off the white spaces, right? Let us try this. Okay, now you can see that the white space has been removed, right? So we first located where the content was using a combination of tag and class, that is attribute, okay? And then we extracted the content between the opening and closing tag, and then we just cleaned it up so that we have the right information that we require. So we'll store this in mobile underscore name, right, so that we can use it later to create a table or data frame, right? So you can take a look at this again, right? So in a similar way we have extracted the details of the mobile phone using a combination of tag and attribute, and then we have done some cleaning or tidying up to get the exact information we need. So you can go through the other examples as well. It is very similar. First you identify where the content is located using a combination of tag and attribute. Now once you do that, then you extract the content between the opening and closing tag using HTML underscore text, and then you clean it up so that you can use it for further analysis. So we are sharing the slide and the scripts used in the blog. You can go through them, you can try them, and if you have any questions you can always reach out to us. Thank you for watching and please subscribe to our YouTube channel for more such tutorials.